So today we are going to focus a little bit more on the quadratic formula and take a look at it graphically and see what else we can do with this formula. So we have the formula again up at the top in case we forgot it. Again, good thing to commit to memory. And in the last lesson, we had practiced the formula itself. Okay. In this lesson, we're going to practice a little bit more, but we're also going to see how it relates to the graphs. So we are first going to consider the quadratic function. We have x squared minus 4x minus 36, and we're going to algebraically determine the function's x-intercepts. So x-intercepts are where it would cross the x-axis, which would mean the function itself would equal 0, or your y values would equal 0. So we are going to do this because it's saying express this in simplest radical form. We may think maybe I could factor. This phrase right here, simplest radical form, would probably give me the clue to think, let's use the quadratic formula. So first thing we're going to do, like we've done in the past, is we're going to figure out what our A, our B, and our C is. So our A value is 1, our B value is -4, and our C value is -36. So using that, we're now going to plug it into the formula, and then we will simplify. Okay, so we have x is equal to -b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Right, and we're going to simplify. So you could actually, with your calculator, type all of this stuff right in, everything under the radical. So you could do that in parentheses, -4 squared minus 4 times 1 times -36 to kind of help speed the process up. This 2 negatives, remember, makes it a positive. If we plugged all of that into your calculator and simplified, that's going to get us 160. And then we're going to divide it by 2. Okay, so now we need to simplify this, and we need to express this as simplest radical form, meaning I need to split this 160 up into 2 smaller radicals where one is a perfect square. So I can split 160 up into 16 and 10. Okay, and if I divide that by 2, okay, now we're going to continue to simplify. So the square root of 16 is our perfect square, and that's 4. Okay, so that's going to get us 4 plus and minus 4 radical 10 all over 2. And now again, simplest, we need to simplify this down. 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 4 twice. Okay, so our final answer that we're going to have here, I'm going to write this down here in part B, is x is equal to 2. Oops, daisies, let's try that again. X is equal to 2 plus and minus 2 radical 10. Okay, so that would really be our answer up here. I just kind of ran out of room. And the part B is saying express the x-intercepts of the quadratic to the nearest hundredth. Well, both of these are x-intercepts. Keep in mind, we can write this in 2 separate ways. 2 plus 2 radical 10, and we could also have this as 2 minus 2 radical 10. Okay, so now if we need to get this into the nearest hundredth, again, we would use our calculator to do so. And nearest hundredth, this is going to be approximately, and again, you may want to just check this on your calculator, make sure you're doing this correctly. It's about 8.32. And then for this one, this is approximately -4.32. So there's our answers. There's our x-intercepts rounded to the nearest hundredth. Over here, this was our x-intercepts, but in exact form, in simplest radical form. And now we're going to use our calculator to sketch a graph of the quadratic on the axes. Okay, and so the calculator that I have with us today is Desmos. You can also do this on your graphing calculator. So here's Desmos, and notice what we find here. Our x-intercepts, here's the one that we found, -4.32, and now they're rounding this to the nearest thousandths. So we have a little bit of a different rounding situation here. And then over here, I have about 8.325. And now a couple of other points to take note of if you were to sketch this on your graph. The y-intercept is at 0, -36, and we have our turning point at 2, -40. So if we were to go and actually graph this out, okay, a couple of things we could mark on here. All right, we know the y-intercept we said was at about 0, -36. So I'm just going to roughly sketch this. We knew the turning point was roughly at around -40. Okay, and it was about over 2. And then we had our x-intercepts that we found at about -4.32. We hit our y-intercept, our minimum, and we come back up. And mine's not beautiful, but I have my important points labeled, my x-intercepts, my y-intercepts, and my turning point. I also have some arrows, and then the very last thing I'm going to do is give it our label. And you could either say f of x, or you could put the whole equation on there. Okay. For number 2, we're going to do the same thing. We're going to solve for the x-intercepts of this graph. Okay, so if you're just looking at this, now it doesn't give you that hint of simplest radical form. You could try and factor it. If you try and factor it, that's one way that you could solve this. And this will actually work. This will give you some rational values for answers. We are going to try using the quadratic equation just because we are practicing that right now. So the first thing, again, identify your A, your B, and your C. And your A value this time we have 3. Your B value we have a -19. And your C value we have 6. Okay, so plugging this in to our formula. So we have x is equal to -b plus and minus the square root of b squared minus 4 times a times c all over 2a. Right? And again, you can plug that middle information, the stuff all underneath the square root, right into your calculator. So this, I know 2 negatives make it a positive. If I were to plug all of that into my calculator, and I would highly suggest you try it to make sure that you're getting the correct answer, you get 289 and then divided by 6. Okay, so now it just wants the x-intercepts. It doesn't give us a specific way to have it expressed. I would first just try this in my calculator and see what I'm going to get. I know that the square root of 289 is a perfect square. So I know that that's going to simplify down to 17 all over 6. And so now we can get our 2 answers, 19 plus 17 divided by 6 and 19 minus 17 divided by 6. And when we simplify, our 2 answers we're going to get are going to be 1/3, and then we're also going to get a value of 6. Sometimes set notation to tell you answers, they would list it like this. Okay, we are going to move on and try exercise number 3. So we have the Crazy Caramel Corn Company modeled the percent of popcorn kernels that would pop. And we did this a while back. We had this as a different problem. P was representing the amount of kernels that would pop as a function of the oil temperature, that's our capital T, in degrees using this following equation. It says the company would like to find the range of temperatures that ensures that at least 50% of the kernels will pop. So we have to write an inequality whose result is the temperature range that the company would like to find. And we have to solve the inequality with the help of the quadratic formula. And then we're going to round all temperatures to the nearest 1/10 of a degree. Okay, so first thing I'm taking note of, a couple of things here. I see the negative, I see it's a quadratic, and I'm thinking to myself, I know that this is some sort of a function that's got to be opening down if it's a negative a term. Okay, and I know that it has to ensure that at least 50%, those are keywords there, at least 50%, meaning that's our minimum. So it could be more than that, but it has to actually hit at least 50%. So that gets me started with our equation saying a -1 over 250 t squared plus 2.8t minus 394 has to be greater than or equal to that 50. And we need to solve this. Okay, so in order to solve this, kind of like we did before with our x-intercepts, I'm going to have to bring our 50 over to the other side. So I'm subtracting 50. So now I have a negative 1 over 250 t squared plus 2.8t minus 444 is greater than or equal to 0. So I at least want to see where it's equal to 0. So I'm going to kind of treat this like I would if it was an equation. And I'm trying to solve, I can think for x. Okay, so it'd almost be like treating it like this one back here. Oops, not that one. Where we did back here where we were trying to set them equal to 0. Okay, same idea. We're going to have this set equal to 0 and we're going to solve. So we're going to use the quadratic equation because I don't know about you, but I don't really feel like trying to factor that. But our quadratic equation, I can say I know my a value is a negative 1 over 250. I know my b value is 2.8, and I know c is negative 444. Okay, so with all of that, I can plug that into that formula. This is a fantastic example of why this formula works, and it's amazing. So I have a negative b plus and minus the square root of b squared minus 4 times a, be careful, this is your fraction, times c all over 2a. Oops, and our a value we know is negative 1 over 250. So I can't stress the importance right now enough about using your calculator, using the parentheses around the calculator, and entering this in and checking this. And please make sure that when you check this and you plug this in, you're getting the right answer or the answer that I'm putting up here. Okay, so if we simplify this, I'm going to tell you what I got when I plug this in. I have a negative 2.8 plus and minus. All of this stuff under the radical, when we simplified that down, 0.736. If you are not getting that, bring your questions to class and we'll try it in class together. Okay, and on the bottom, again, when we multiply that out, that's a negative 0.008. Okay, and so now if we plugged each of those into our calculator individually, okay, so we'd have to do the negative 2.8 plus the square root of 0.736 divided by negative 0.008, that gives us one answer. And then the other one would be negative 2.8 minus the square root. So when we do that, and again, you need to try this on your calculator, the two answers that you're going to get here are 457.2, right? Or our other value is going to be about 242.8. Okay, so those are our two values. So now it says we have to write an inequality whose result is the temperature range. We have to solve the inequality we just did. We're going to round our temperatures to the nearest tenth of a degree. So what it looks like to get that at least 50%, the minimum value would be 242.8, but it could be greater than, but it can't be any bigger than 457.2. So notice the signs, notice what it's saying. Temperature has to range in between 242.8 and 457.2 in order to get that 50% that they are looking for. Okay. Now we have one more here. So we're going to find the intersection points of the linear quadratic system below algebraically, meaning a line and a parabola. And then it says we're going to use our calculator to produce a sketch of the system, label the intersection points that we found. Okay, so we've done this before. We've said if they're equal, set them equal. Okay, they're both equal to y. That's why I know I can set them equal. Plus, I'm trying to see their solution, their points of intersection. The only way I can find their points of intersection is if I actually set them equal. So I have 6x minus 3 is equal to 4x squared minus 6x plus 2. Okay, no matter what, if I tried to use the quadratic formula, factoring, completing the square, no matter what, I have to get all of this stuff over to one side of the equation and set it equal to 0. So I'm going to subtract the 6x over. So I have a negative 6x minus 6x, that gets me a negative 12x. I have a plus 2, and now I have to add the 3 over, so that's going to get me a plus 5. Okay, you could try and factor it. That's an option. We are going to practice this using our formula. So our A value is 4, our B value is negative 12, and our C value is 5. Okay, so we have x is equal to our negative b. So negative 12, that's a positive 12, plus and minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, and so now again, you could plug this in your calculator and simplify this, solve this. Make sure, again, check this out, make sure that this is working. So we have here the square root of, if I simplify this all under the radical, that gets me 64 divided by 8. And the square root of 64, well, that's a perfect square, so that's nice. That's going to get us 8 over 8. Okay, so one answer we have is 12 plus 8 divided by 8. All right, and that's going to get us about 2.5. And then the other answer we have is 12 minus 8, so that's 4. 4 divided by 8, that would get us 0.5. All right, but we're not done because these are intersection points. So what that means now is we have to go back in and we have to solve for the other, for the coordinates, for the y value that goes with it. And you could plug it into either one. I'm going to probably pick this line here because to me that's a little bit easier to work with. And I'm going to plug in to begin with the 2.5. So when x is 2.5, we're trying to see what is the y equal to. So that would be y equals 6 times 2.5 minus 3. Okay. If we simplify that down, that's going to get us 12. So if I put them together, I have one coordinate at 2.5 comma 12. That's one point of intersection. And the other point that we would have, I'm working with x equaling 0.5. So now I have y is equal to 6 times 0.5 minus 3. And simplifying that, that's going to get us 0. Okay, so my other answer that I would have here is 0.5 comma 0. So now we've found our intersection points. We've found the two solutions. And now we're going to actually graph them out. So again, I'm going to go back to Desmos. And we are going to get a new graph. So I am going to graph first our parabola. So I have 4x squared minus 6x plus 2. Here's our parabola. And now I want to graph our line. The equation of the line, we have a 6x minus 3. And now I want to see their points of intersection. So if I zoom out, I can start to see where they're intersecting. And here's one, and we found that one point of intersection. Here's our other point of intersection. We found both of those. Okay, and then if I were to try and graph this on our paper, other points that you would want to take note of, you'd want to probably take note of the y-intercept of the line, the y-intercept of your parabola. Okay, you'd want to maybe take a look at the vertex of your parabola, the two x-intercepts of your parabola, and then you could copy that over onto your paper. Okay, and so on the bottom, it just says, note the fact that the solution to the system were rational numbers indicates that the quadratic equation in 4 could have been solved using factoring in the zero product law. So because they were nice factors, they were nice rational numbers, this 2.5 is a rational number and the 0.5 is a rational number, you could have factored. Did you have to? Nope, quadratic formula will always work. Okay, so Hopefully, this wasn't too bad. Hopefully we learned some stuff from this. If you have questions, please bring them into class. If you're not able to get those correct values on your calculator, please bring that to class and let me know, and we will work with that. Okay. Hope you guys have a great day, and I will talk to you later.